So today we're doing 2.7, which is arithmetic sequences, and this is a totally brand new concept. Before we start, we're going to add some vocabulary to our notebooks, and then we're going to do just a little bit of work in our textbook, and then we'll get the rest of our notebook page in. Okay, so we should have function notation written in our vocab page already. So the next term that we are going to add is a sequence. A sequence is an ordered list of numbers that often form a pattern. So it's just a list of numbers that usually form a pattern. So the example I gave was 4, 7, 10, 13. Does anybody know what the pattern for that one is?
Plus 3.
Plus 3. Okay? So that's a sequence. Okay, sequences are made up, so a sequence is the list, and the individual numbers in the list are what we call terms of a sequence. Okay? So the term of a sequence is each number in the list of the sequence. So I made up another sequence, 4, 8, 16, 32. Does anybody know the rule for that one? Times 2. But what I did is I labeled each individual term. So 4, 8, 16, 32 is the actual sequence. 4 is the first term, so we call it term number 1. 8 is the second term in the list, so we call it term number 2. So what would term number 3 be? 16. What would term number 4 be? Does anybody know what term number 5 would be?
64.
Good. Okay, so the entire list of the numbers, that's the sequence. Each individual number is called a term. Okay? Okay, so problem number 1 on page 146. We're just going to do a couple of these and then move on. What we have to do is look at a sequence, and then we need to describe the pattern and determine what the next two terms are. So in part A, I'm going from 5 to 6, or sorry, 5 to 11, 11 to 17, 17 to 23. What's the pattern? Plus 6. So we add 6 each time. So here's how I want you to describe the pattern. Add 6 to the previous term. I just gave you guys the answer. So we take the previous term and then we add 6 to it, right? So after 23, what would be the next term? 29, and then what would be the one after that? 35. Okay. The ... at the ends of the sequences mean that it goes on forever following that same pattern. Okay. Okay, so then let's look at part B. 400, 200, 150. What's the pattern there?
Divide by 2.
Divide by 2. Now, hold on. Before to the previous term, or from the previous term, before you guys write divide by 2, with sequences and especially when we're talking about sequences where the pattern is multiplication or division, this is going to come up later on in the year, but I want you to get into the habit of it now. I do not want you to write the rule or the pattern as division. How can we rewrite divide by 2 as multiplication? Read here.
Times 1/2.
Times 1/2. Okay? So multiplying by 1/2 is the same as dividing by 2, right?
Yes.
Okay? Just so write it as times 1/2. The reason why we do this is because eventually we're going to write the rule for the pattern. And when we're writing the rule for a multiplication pattern, we always write the number that we multiply by each time, because there's not a way to write that in the rule as division. So just so you guys are getting used to it, okay? Same thing with addition and subtraction. Subtraction is really adding a what?
Negative.
A negative, okay? So dividing is the same as multiplying by the fraction, okay? So then the pattern would be to multiply the previous term by what? By 1/2. By 1/2. So then what would be the next term?
25.
25, and what would be the term after that? 12.5 or 12.5? ... Okay? Not too bad? Yeah. That's half of your homework, is just figuring out the pattern and telling me the next two terms. Easy, right?
Yes.
Okay, so let's make it a little more difficult.
Oh, why?
Oh, you want to do C really quick?
I already got it.
Okay, how do I get from 2 to negative 4? Times negative 2. Does that work for the next one? Negative 4 times negative 2 gives me positive 8, and then if I times negative 2 again, that gives me negative 16. So anytime we're going back and forth from positive to negative, it's always times a negative. Okay, so that's a sequence, is when we have a list of numbers that follows a pattern. So what we're going to be looking at, and we looked at two different types of sequences, one where the pattern was addition, one when the pattern was multiplication. We are only going to be talking about sequences where the pattern is addition. Okay, so that's what we're working on today. That is called an arithmetic sequence. Arithmetic, like arithmetic. Arithmetic means adding and subtracting. Okay, so an arithmetic sequence is a sequence in which the difference between consecutive terms is constant, meaning I add or subtract the same number every single time. Okay, so in the sequence 2, 4, 6, 8, what is my pattern there? Plus 2 every time, so that's what makes it arithmetic. The number that we are adding each time, so the plus 2, plus 2, plus 2, is what is called the common difference. The common difference is the difference between terms in an arithmetic sequence. It has a special letter, D. So in the previous example, the common difference would be positive 2, because we're adding 2 each time. So now what we're going to do is we're going to look at a couple sequences. We're going to determine if they are arithmetic or not. So some will be, some will not be. And if they are, we're going to figure out what the common difference is. Okay, so that's problem 2. So let's look at problem 2. So you probably need to turn the page. Okay. Okay, so problem 2, part A. 8 to 15. What do I need to do to get from 8 to 15? Plus 7. What about from 15 to 22? Okay, what about 22 to 30? Plus 8. So is this one arithmetic? No, because we are not adding the same number every single time. So we would say not an arithmetic sequence. So do we have to find a common difference? No, because it's not an arithmetic sequence. So then let's look at B. In B, how do I get from 7 to 9? Plus 2. What about 9 to 11? And then 11 to 13? Okay, so is this one arithmetic? Yes. Yes, so we will say arithmetic sequence. And since it is, we can say that D is what? Positive 2. So far, so good? Okay, do C and D on your own. Okay, part C, 10, 4, negative 2, negative 8. What is this one arithmetic? What was the common difference? Negative 6. What about part D? Okay, but is times negative 1 arithmetic? No, because arithmetic means that we are adding or subtracting the same number each time. Even if we are multiplying the same number each time, it is not arithmetic. That's what we call a geometric sequence. Okay, so if we are multiplying something each time, it's called a geometric sequence. The number that you are multiplying by every time is called the common ratio. Multiplication, ratio. But we are only worried about arithmetic. Okay, so even though in part D we're multiplying negative 1 each time, it's not arithmetic. Okay, so what we're going to do now is I'm going to give you the arithmetic sequence, and I'm going to have you guys write the equation for the sequence. But first, let's get our notebook set up. So, we're on page 32, 2.7, arithmetic sequences, date it. And then we're going to start with what we call the recursive formula. So the recursive formula is a function rule that relates each term of the sequence after the term before it, which should make sense. Re means what? Again. So recursive means that I have to go back to the previous term. Okay? So write that definition for me, and then we're going to add something to our notebook. So this is what it should look like. So now we're actually going to put in on this part the formula. So there's going to be the formula, the generic formula, and then we're going to practice by making a formula out of a sequence. Okay, so here is the formula, A of n. That's function notation, right?
Yeah, wait.
What do you think the A stands for? Arithmetic. The N is the term number. Okay, so this means the sequence for a specific term number. We call that the nth term. So underneath the flap, label it nth term. Nth term. In math, when we don't know what the number is yet, we call it the nth number. Yeah. Once we do a problem, it's actually going to have a number in there for n, okay? So if I am looking for A of 4, that means I'm looking for the fourth term. Does that make sense? If I have A of 1, that means I'm looking for the first term, okay? But when we don't know what n is, we have to call it the nth term, okay? That's A of n equals,
Oh, this is so smart.
equals A of n minus 1. So let's think about what this might mean. If A of n is the current term that I'm looking for, what do you think A of n minus 1 would be?
You just had a minus term before that term.
The previous term, because what does minus 1 mean?
Minus 1.
If I'm looking for the fourth term, so A of n minus 1 would be the third term, because 4 minus 1 is 3. So that would be called the previous term.
That makes sense.
It should make sense because we are looking at a recursive formula, and recursive means we take the term before the one we're looking for.
It's going to be plus A of n.
Not quite. Plus,
It's plus.
plus the common difference, the number that we're adding each time. So plus D.
Oh, that makes sense.
So what this is saying, and let's write common difference under there. What this is saying is when I'm looking for the nth term, whatever number I tell you to plug in for n, it's going to come out to the previous term plus D, plus the number that we're adding each time. Does that make sense?
Yeah.
So like if I have 2, 4, 6, that's 3 terms, right? To find the fourth term, I take 6 and I add 2 to get 8. So I have to take the third term and add 2. So we're actually going to do an example of this, okay? So example 1. Is going to be to write a recursive formula. For this sequence, 70, 77, 84, 91, ... means it goes on forever. Okay. So example 1, we're going to write a recursive formula for the sequence 70, 77, 84, 91. Before we even start, what number am I adding each time?
7.
Plus 7, right? So I'm going to write that plus 7. I think the arrows help. Okay? So then we're going to use the recursive formula to write a formula specifically for this sequence. Now here's the thing. With a recursive formula, we can't find the next term unless we know what the previous term is, right? But we also have to, if I just give you the formula without giving you the previous term or a starting term, it's not going to help us at all. So we always want to give the first term. So we say A of 1 to start. Okay, so A of 1. That means when n is 1, or my first term. What is the first term? 70. So we start the formula by saying A of 1 is equal to 70. So it's kind of like saying, here's your starting point. The first term is 70. Okay, and then we're actually going to write the formula. A of n equals A of n minus 1. So whatever term I'm looking for, you can tell me which one I want. It's going to be the previous term plus what? 7. There's your recursive formula.
Oh,
That's all you have to do.
wait, that's it?
Yep.
You don't have to plug it in? Or...
Isn't there like trick to this?
Well, the next thing I'm going to do is then I'm going to ask you to find a specific term. Okay, so make sure you have this written down first. So now we're actually going to use this formula for this sequence to find the 8th term.
Well,
So the next question is find the 8th term.
those ones are different colors.
Okay, so the next part for this is going to be to find the 8th term. So guys, if I'm looking for the 8th term, that means I need to know which term before that.
The 7th.
The 7th term. Do I know the 7th term?
No.
No. So that means to find the 7th term, I need to know the 6th term. Do I know the 6th term yet? No. So to find the 6th term, I need to find the 5th term. Do I know that one?
No.
Okay, so to find the 5th term, I need which one? Do I know the 4th term? Yes. Okay, so we have to start with A of 5.
Did it.
Yes. So A of 5, the 5th term, is equal to, and I want you to show all of this work, A of 5 minus 1. What's 5 minus 1? 4. So you can just write it as A of 4. If you want to put A of 5 minus 1, that's even better.
Sorry.
Plus 7. What's A of 4?
A of 4 is 9.
A of 4 is 91. So that's 91 plus 7, which is 98. So the 5th term is 98. Okay? So then can I find the 6th term?
Yeah.
Okay, so the 6th term is A of 5 plus 7. A of 5 is 98. 98 plus 7, 105.
This is easy, it just takes a while.
Right. That was what you could catch.
Okay, so then we have A of 7, which is A of 6 plus 7. A of 6 is 105. 105 plus 7 is 112. And now we can find A of 8.
I feel like
Finally.
there's a lot faster way of doing that. Like, couldn't you just do 91?
You could just go up and
We
I feel
know.
like you could just count.
Well, once we get to, but I want you to find the formula. So then A of 8 should come out to
119.
119.
So much work.
Show our work now.
Guess what?
chicken butt.
So here's the kind of thing. The recursive formula is really easy to come up with, right?
Yeah.
But it's kind of difficult to use.
Yeah.
There is another formula. It is called the explicit formula.
Which is even longer.
It is. Okay, so here, we're going to write the definition, and that's probably going to be about as much time as we have, okay?
It sounds kind of painful.
So here is the explicit formula.
Sounds like my kind of formula.
That's good.
What's in here?
Okay, so the definition of the explicit formula is a function rule that relates each term of a sequence to the term number. So basically, we're going to be able to come up with a formula for any type of arithmetic sequence where I say find the 100th term. You can plug in 100 and it will give you the actual term.
What?
Yes. Preview for what's to come on Monday.
No.